Hello, I'm Vikrant. The question is, Ramesh travels 600 km to reach home, partly by train and rest by car. He takes 8 hours if he travels 120 km by train and rest by car. But he would take 20 minutes more if he travels 200 km by train and rest by car. Find the speeds of train and car. The solution is, let us assume the speeds of train and car be x and y kilometers per hour. So we can frame the first equation as, the question is, he has taken 120 kilometers to travel by train in 8 hours. So we can frame the equation in terms of time, taking the total distance, that is 120, upon the speed of the train, that is x we have assumed. Similarly, the total distance now remains as 480 because the total was 600, out of which 120 was travelled by train at a speed of y. The total time turns out to be 8 hours. So this can be framed as equation number 1. Similarly, we can frame as equation number 2, that is 200 kilometers he has travelled by train. So 200 kilometers is travelled by train at a speed of x, remaining is 400 which is travelled at a speed of y. The total time turns out to be 20 minutes more, that is 8 plus 20 minutes more. So it turns out to be 200 by x plus 400 by y, which is equal to 25 by 3. The equation number 2. Solving these two equations, we get the value of x as 60 and y as 80 kilometers per hour. Therefore, answer is second. Thank you. Hello, I am Vikrant. The question is, a man can row upstream at a kilometers per hour and downstream at b kilometers per hour. He rows up to a certain point and then returns to his starting point and finds that average speed is s kilometers per hour for double journey. Express each of the letters in terms of other two. The solution is, let us assume the total distance is equal to d kilometers. So the time for the upstream is to be calculated taking speed as a kilometers per hour. So the time for upstream will be equal to the total distance, that is d, upon the speed, that is a kilometers per hour. Similarly, the time for downstream will be equal to d, that is the total distance, upon speed, that is b kilometers per hour. So we can say that average speed is equal to total distance upon total time. So that turns out to be d plus d, that is the total distance upon total time, that is d by a plus d by b, that is 2d upon db plus dA multiplied by a into b. So it will turn out to be 2ab upon a plus b, which is given as the total distance. Therefore, answer turns out to be first. Thank you. Hello, I am Vikrant. The question is, a boat goes up a river 20 km and down a river 24 km in 8 hours. It also goes up a river 30 km and down river 28 km in 11 hours. Find the speed of the boat and river. So the solution is, let us assume that downstream speed is equal to x kilometers per hour and upstream speed as y kilometers per hour. So we can write the first equation as 24 kilometers upon the total downstream speed, that is x, plus 20 kilometers upon y, that is the upstream speed, which will be equal to the total time taken, that is 8. This turns out to be equation 1. Similarly, we can frame the equation 2. It goes up a river 30 km, that is 30 by y plus 28 by x plus 30 by y, which will be equal to the total time taken, that is 11 hours. This can be done as equation number 2. Solving these two equations, we get the value of x as 8 kilometers per hour and y as 4 kilometers per hour. So the speed of the boat is x plus y by 2, which is equal to 8 plus 4 by 2, that is 6 kilometers per hour. And similarly, the speed of the current is x minus y by 2. So these are the two important concepts we will be using, the speed of the boat and the speed of the current. So these two concepts are important for solving this question. So we'll be having the speed of the current, that will be taken as 8 minus 4 by 2, that is 4 by 2, that is 2 kilometers per hour. So the answers come down to be 6 kmph and 2 kmph. Therefore answer is first. Thank you. Hello, I am Vikrant. The question is, two trains starting from same station and traveling in the opposite directions are 227.5 km apart in 3 hours 15 minutes. Had they been traveling in the same direction, they would have been 32.5 km apart in the same time. Find their speeds. The solution is, to solve this question, we need to frame the equation in terms of their speeds. So we can say that it is covering a distance of 227.5 km in 3 hours. That is, we can first of all frame the equation as 3 hours 15 minutes can be written as 3.25 hours. So it will be 227.5 upon 3.25, that will give you the sum as 70 kilometers. Similarly, the difference, that is, the difference is taken only due to the reason that they are moving in the same direction. As we know that when the speed is taken as addition when they are moving in the opposite direction, and the speed is taken as subtraction, that is the difference when they are moving in the same direction. This is the important concept while solving the question which are related to the relative speed. So 32.5 kilometers apart, so we can write it as 32.5 upon 3.25, that will give you 10 kilometers. So now we have the equation as x plus y is equal to 70 and x minus y, that is the difference, is 10. By solving these two equations, we are having the values of x and y, and hence we can say that the faster train is moving at the rate of 70 plus 10 by 2, and the slower train is moving at the rate of 70 minus 10 by 2. So this figures turns out to be 40 and 30 kmph. Therefore answer is second. Thank you. Hello, I am Vikrant. The question is, in accordance with the schedule, a train is to travel a distance between A and B equal to 20 kilometers at a constant speed. If travelled halfway at specified speed and stopped for 3 minutes, to arrive at point B on time, it had to increase its speed by 10 kilometers per hour for rest of the way. Next time, the train stopped halfway for 5 minutes. At what speed must it travel the remaining half of distance to arrive at point B in accordance with the schedule? Solution is, if we assume the speed is equal to x kilometers per hour, then the time t is equal to the total distance, that is 20 kilometers, upon the speed, that is x. So from the question we can say that the speed increased by 10 kilometers per hour, so it will be 10 upon x, plus it has stopped for 3 minutes, so it will be plus 3 upon, it is minutes, it has to be converted into hours, that is 3 by 60, plus 10, that is the half distance, upon x plus 10, it will be equal to 20 by x, that is the total time taken. So by solving this equation we get 20 by x minus 10 by x minus 10 upon x plus 10 is equal to 3 by 60, which will give you 10 by x minus 10 upon x plus 10, which will be equal to 3 by 60. Therefore 1 by 20 is equal to 10 upon x times x plus 10 multiplied by x plus 10 minus x, which will give you 1 by 20 is equal to 100 upon x times x plus 10. So we can frame the equation as x square plus 10x minus 2000. This will give you the equation number 1, and we get the value of x as minus 50 and 40. So neglecting the negative value, we get the positive value as 40 kilometers per hour. Similarly, in the second run, if we assume the speed as y kilometers per hour, we get 10 upon x plus, the question says it takes 5 minutes, half the way for 5 minutes, so it will be 5 by 60 plus 10 by y, it will be equal to the total time, that is 20 by x. It will give you 1 by 12 plus 10 by y is equal to 10 by x, which will be equal to 10 by 40, or it will be equal to 1 by 4. So the final equation turns out to be 10 by y will be equal to 1 by 4 minus 1 by 12. It will be equal to 12 can be taken as the LCM, so it will be 3 minus 1, that is 10 by y is equal to 1 by 6, or y will be equal to 60, that is 60 kilometers per hour. Therefore the answer is first. Thank you.